Good morning, everybody. Well, I just left the post office, and this is the eBay package, the EICO 950B capacitor bridge comparator. And I'm going to open the box. And I got little leads here, which are not EICO originals, but that's nice because I don't have leads. All my test gears don't have leads, and this comes in handy. Alright, well, here's the EICO.
Material here to ship out stuff myself. I kind of saved this bubble wrap to some extent. Can't save all of it, but save what I can. One thing's for sure, it's packed fairly good. Part of the video up here. It gets kind of boring going through all this. Quite rapid here. We're getting there.
Yeah, nice looking unit. Hope it works as good as it looks. Snip the wire tie off the cord here. Switches feel real good. Dial drags, the plastic pointer drags on the faceplate, but I guess that's no big deal. The biggest thing is, let's try it out. So let's we'll plug it into the variac. Get the variac down. Alright. Oh, helps if I turn on my outlet strip. Alright. See, we bring her up. First of all, let's turn it on. Alright, I got 53 volts going into it. Put 77 volts. $85. $100. All right, iTube is just starting to glow. All my equipment's going to have a grounded 3-prong cord and plug eventually. All right, let's bring her up to 116 volts. I have to shade the iTube. Seems like it's not very bright. Alright, that's 114. Let's bring it up to All right, 117. All right, well, I'd like that eye tube to be a little brighter. That's not very bright. It's not very bright at all. I don't like the looks of that. The one I had didn't do that. Set the capacity all the way up here. I don't think this is working. That should not open. The eye tube should not open. Yeah, I don't think so anyways. I could be wrong. The only way to do is tell. It's awful hard to see this eye tube. Just very dim. Another thing too, they put Phillips in here, and that's what I did on mine. I hate working with slotted screws. A screwdriver always slips off. So they put in slotted screws. I mean Phillips screws in place of the slotted ones, and that's a good thing, because they had this open obviously. But cosmetically it's good, but I have a feeling that this is going to have to be worked on. $54.95 for this with the shipping. Alright, I can't really get any further back right now. I'm going to fall off the edge of the bench with the camera, that is. I've got my voltage probes in the capacitor test and voltage test, which is the jacks on the right hand side of this unit. And over here on the left hand side down here is the voltage control. This is the standard size. This is where you would compare your capacitor or whatever resistor. But we're using the right hand connectors to monitor the voltage. So the voltage is set at 0 right now, and we're going to turn up the control to 100 volts. Okay, that seems to be about right. Very hard with my eyes. 250 volts. It's a little low, but I don't expect these controls to be that linear. And we'll just go all the way up to supposedly 500. Then 417. So it's low. So I suspect that it needs capacitors. But what bothers me more than anything else is this eye tube is very, very, very dim. So what I'm going to do is I'm going to open this up. But before I even do that, I'm going to try to see if the capacitor function works on this. But boy, it's hard to see that eye tube. Anyways, this voltage is being read, of course, without a capacitor across it. But I had one of these units, so I know how they work. And even without a capacitor, you should be able to get voltage close to 500 volts, not 417 volts. Here is a Sprague .025, brand new, well, new old stock, a .025 microfarad. We're going to try that in here. So, get my reading glasses on here. Alright, .025. Alright, 025. Okay, that's going to be way over here. Alright. 0.001 to 0.5 microfarad. So that's the scale. The 001 is the second scale, the reading. So 025, 015, 02, 025 should be right about in here. The capacitor bridge seems to be working, and she's pretty close. She's between 02 and 025. So it seems like the bridge is working on capacitors. It's just that this I-tube is so damn dim. Now I'm hoping that it's maybe because I'm not getting only but 418 volts, 417 to 18 volts maximum out of the voltage control for the breakdown voltage here, the leakage. That maybe the whole B plus is down, and that's why this isn't lighting. This is very dim. This is nowhere near as bright as the signal tracer I-tube, and just barely see it. This is about as dim as the one I owned. That I had a 950 bridge, and the I-tube went so dim that I couldn't even read it anymore. And that was my mistake, because I left this thing on for a week in the workshop, because this don't stand out that much. So I had added a bright red pilot light on the faceplate of this, on the one I had, so that I'd make damn sure that I turn these off. Because when you walk out of the shop and you see a little red light still on, you know you got to turn your equipment off. So we're going to be putting a pilot light on this, but what I want to do is I want to check an electrolytic now. We'll come back in a second here. All right, here's a capacitor one of my viewers sent me. It's a 400 volt rated capacitor, 120 microfarads. Now it's a radial lead capacitor, so thank goodness they sent me leads for this. Looks like brand new leads. They're not original, but they'll work right on the binding post here. So we're going to need them to clip onto here. So we turn the voltage down. Make sure it's down. We set the plus up here. And we're going to double check this voltage again to make very sure that the polarity isn't reversed. I don't think it is. But you don't want to put reverse polarity on the capacitor. So we're going to check the voltage and make sure it is reading plus, and I'm pretty sure it is, before anything. Now, from what I understand and what I read, and trying to go from memory here, that in the capacitor test bridge section, there's usually a small AC voltage applied to the capacitors under test when you're checking for capacity, not for breakdown, but for capacity. So that could very well be. So we're going to put the meter on here, and we got the meter right here. I will just look off. I'm not going to move the camera, not necessary. You can take my word if there's any voltage on it. I'm reading, all right, on DC I'm reading 18.62 volts on the setting of the paper capacitor, the 0.025 that I just showed you. Let's see what she reads on DC. 48.6 volts. Check the next position down. On AC, I'm sorry, AC. AC was 49 volts on AC. 18.67 volts on DC. So we'll say leave it on AC. We'll put it back on AC. That beep here is my change in the mode of the meter. All right, let's go through on the lowest capacity. The 49 AC, 49 AC, 57 AC, 49. These are all AC volts. 49, 45, 51, 17. We're getting into 17, and that's the comparator mode. And now on the paper mica test, I'm reading 0.061 volts, but that's AC. Is it all AC now? I'm just going to switch it over to DC. 0.649 volts, all insignificant. Let's see what she reads on the electrolytic test. This is for capacity. No, it isn't. It's for breakdown. Okay, so we'll disregard that last one. So, okay, we're going to go into the electrolytic test now. Let me check the capacity of it now. Let's go to the, it's supposed to be 120 microfarads. So let's see where we are now. Excuse me, I got to magnify everything I look at here. All right, we're all the way down to the bottom, 10 microfarads to 5,000. Been a while since I used one of these. Okay, 120 microfarads. All right, here's 100. I'll tell you, this iTube is so dim. I can't even see that. I cannot even see that iTube. Oh. I cannot read that. That's the power factor. I was operating the voltage control. I'm telling you, I'm just not using, my head isn't on me, screwed on too good today. That's the power factor here. Well, let's put it on the electrolytic test. Alright, I can see that. But we got to keep an eye on this. She's taking the charge, I'm pushing it up to, as I don't have my meter on it. Hang on a minute, let me put the meter on it. $90, 100 volts. I'm not touching it now. She's climbing. 115. 116. Okay. 136. Alright, we'll turn the control again. And I'm watching the eye here. 190. Alright, so we're at 211 volts. I'm going to turn it up. The dial is reading higher than what the voltage is, but I'm not worried about that too much because I've always monitored with a voltmeter. So let's just push it up a little bit more here. It is a 400 volt capacitor. It was in service. I can see solder on it, but it looks like it's in real good shape. And it's taken the voltage quite well, as you can see with the iTube here. 300 volts, I haven't touched it, it's just forming up. 308, 310. Alright, she's climbing. But I can just barely see that iTube, I'll tell you. That is one of the dimmest ones I've ever seen. It's a 1629 tube. That's what they use in here. I just pushed it up. It's climbing to 350 volts now. And we'll just let it slowly form up. And then we know that that function is working. But I can't read the capacity. But the biggest problem is I can't see the eye tube. It's not bright enough. I'm going to open this up. And I want to check voltages. I don't have the schematic with me. I'm going to have to look it on the PDF. See what the voltage is. But I want to run some resistance checks and everything, and take a look on the inside of this. Alright. She's right on 400. Okay, what I'm going to do, disconnect the capacitor from the bridge. She's charged. The bridge is putting out 402. I haven't touched anything. So, voltage is good. Now I'm going to turn the control all the way up on the bridge again, now that it's warmed up. And let's just see. The dial is reading 450 on the dial. The dial is sitting right on 500. She's still only 417. Okay. Now there's no capacitor, because I got the capacitor right here. Now you can turn down the voltage control without having sparks and everything else inside the control. And the capacitor has been off the bridge for a while. That's a good capacitor. Nothing wrong with that. Alright, I'm going to open this up. I think it's the eye tube that's is weak. But I'm hoping that maybe it's not getting enough voltage. Maybe there's a resistor out of tolerance or something. And that might be all that's wrong with it. So we're going to shut it off. Well, the eye tube has been replaced 5/22/1981. And from the looks of it, looks like it's got a new replacement electrolytic in there. There's a paper cap here that hasn't been changed. And this could be the 2 microfarad bridge capacitor. But the bridge seems to be working pretty good. So I wouldn't think that would be bad. Well, I know one thing. All these here are loose. This is your comparator side. This is where you do all your testing on this side. But nevertheless, that's loose. And this is the voltage control, a wire wound pot. Usually, I think it's a 5 watt. And these are known to be defective because the guys, when they discharge a capacitor, they turn the voltage control all the way down to 0 to discharge the capacitor. And what happens is the high current, you've seen how that capacitor sparks, literally burns out the control, usually at the low end. And sometimes it burns it right out to become useless. Other times you may have a bad area at the low end. So you always discharge the capacitor. You're supposed to do it through a resistor, and I just shorted it with a screwdriver, but I just wanted to show you how much current is in them things and can cause a lot of damage here. Remember, it's not the voltage, it's the current. So we got this to fix, and we got capacitor to replace. You got the main electrolytic down there, which is going to have to be replaced. I mean, I don't expect the thing to be restored, Well, what bothers me is the eye tube being very, very dim. So, that's what bothers me. I have no way of testing. I built an eye tube tester. If you followed my videos going way back when I had my shop. I got rid of it with all my stuff. I built it's a simple little tester that used a power transformer out of an old junk EICO 232 VTVM, which had a bad meter, and I used a transformer out of it to make a little simple test jig to check these eye tubes out. And it didn't supply no 200 volts to the target and the plate of this tube. It provided about 130 volts. So if your eye tube was any good at all and it showed up on showed green on that particular tester, you know damn well that eye tube is good. Well, anyways, the only thing I can do here is to measure these voltages, and I'll have to go first and check the schematic out and see what the voltages are. This is an 8 microfarad at 525 working volts. No way you're going to be able to get that value, that voltage rather. So it's only 8 microfarads. So I'm inclined to believe that that should be replaced. And there's 2 small capacitors, 450 volts in series, probably 8 microfarads. 2 20s in series would give you 10 microfarads. Capacitors in series half, resistors in series double, just remember that. And we're going to look in the box and see if I have anything, otherwise I'll have to order something, and when I do I'll probably order caps for this. I have not found the 2 microfarad standard bridge capacitor. This is 2 microfarads, but that looks like an electrolytic. This is 0.25 at 600. These connections here seem to be tight. That's the voltage. But this capacitor here, it's got to be the bridge capacitor. The bridge standard. But I'm not going to worry about that because I'm getting pretty accurate readings on the bridge. I'm worried about the low voltage on the output of the voltage control. When turned all the way up to 500 volts is only 417 volts. And it could be the electrolytic and the whole main supply is down low. And maybe that might be why this eye tube here is not too bright. It uses a 6x5 rectifier tube. No other tubes in this other than a 6x5 rectifier, which could be weak too. I have no way of, I got that tube tester, that little tiny tube tester. I might be able to check the tube on this too, because the rectifier could be weak, but I don't have another one to try it out and stick in there. I'm hoping it's a B+ problem and not the eye tube. But 1981, that's a long time ago. Before I go in the house to get the schematic printed out or whatever, I got tired of this damn Harbor Freight thing here falling over on the bench. It's always falling over. It's got such a tiny base on it, it's useless. So in my junk pile in the big shed, this is why I save stuff, it's some nice 1/4-inch thick aluminum. I don't know where I got it, a yard sale somewhere maybe. So I made a base for this. And then I took some particle board, the kind that goes on the back of a radio or something, and I countersunk. I drilled 2 holes so that the screws would not, because this thing was rocking on the screws, so I made a nice base for it now. Now I can put this thing in any position and it's not going to fall over on me. So this will come in handy for working on things too. I think this is a 5x magnifier. That was the only complaint I had with this thing, is the base is so tiny on them. Now I could have made a base out of wood, but it would have been too light. This is heavy. This weighs, the whole thing weighs a good, I would say a good pound. Alright, I just wrote the seller and asked him if he could send, I want to keep the unit, if he has another 1629 I-tube, if he can send it to me, because I really don't want to send this back. There isn't all that much that can go wrong as long as these pots are good. And I'm going to be running tests on them. I tightened these up. The comparators terminals, the voltage terminals are fine. But I suspect that the I-tube is weak, but I haven't measured voltages yet. Well, it's a 10,000 ohm because it says it right on the back. Thank goodness, because I can't read the values at all on these schematics, and I've tried 3 or 4 different places. And apparently, whoever copies these schematics out of the book, they're not good quality scans. So they're very, very hard to read the parts list and everything. Anyways, this pot checks out really good. Reads just about, it's 0.6 ohm down at the low end. And go all the way over to the high end. There's a 10,000 ohm pot. It's reading 10,040 ohms. So it's working really well. And I'm going slow now. I'm going down in value. It seems to be quite well. So the bridge part is good. I was worried about that. The next one I want to do is the this one. This one's marked also 100,000 ohms, so I'm going to put the meter leads on that and we'll check that one out. Well, I wrote the seller about the I-tube, so I didn't want to really ship it out. And even if I had to buy another I-tube, it's not a big deal, but the worst fear is when you buy these things, this controller's open. It was working on, seemed to have been working, putting out voltage, but it's burnt out. It's supposed to be 100,000 ohms. It's open. There's the ohm meters right across here. Now if I take the ohm meter and put it on one end to the other, you know, on each side of the winding, it's a wire wound control, it's open. It's supposed to be reading 100,000 ohms. So, well, I got some good news. I wrote to the seller twice, first mentioning the I-tube in this 950 as a possibility of being weak. And then, as further checking, as you saw in the video, the voltage pot is no good. Although it did vary the voltage to some extent, it's open. It's 100,000 ohms, end to end is open, and it does read somewhat. So I wrote back to him and told him about this, and about an hour or so later I got a notice that he refunded the entire $54.95. This was with free shipping, so he sent back, he put back onto the PayPal the entire purchase price of this unit, and he says, you know, that he's going to be more careful next time with when he puts stuff up on the auction. And he apologized and told me to keep the unit, put your money into it to get it going, and you don't have to send it back. So 100,000 ohm, I think it's a 5 watt or 25 watt, I'm not sure. I'll have to look at this, the book on this and see, but that would have to be replaced. The I-tube, maybe. Oh, I could pull the I-tube. It's a 1629. I could pull the I-tube out of the signal tracer if need be. So that is good news. And you notice the shop has acquired another shelf up here. I'm going to be getting another VTVM from a fellow named Don. The package has not arrived yet as of today. Should be here tomorrow. So I'm going to be getting EICO 235 VTVM, I believe. So I won't be even restoring this here. And then I'll be getting an EICO 324 signal generator. I will probably put that up here on this shelf. And then I got room for the other frequency counter, the Lodestar one that I was mentioning. So those three items will be coming in one box, and I will be doing an unboxing video on it. Well, I'll tell you, there's some good eBay sellers out there.